The U.S. government reports that the percent of uninsured in the country is 13%, the percent who purchase health insurance on their own is 20%, and the percent who purchase insurance through their employer is 67%. A random survey of Americans reveals the set of results below. Does the data provide evidence to contradict the government's claim? So this is the data that we collected from a survey of Americans. They want us to know if this data contradicts the government's claim. So we can see there's 3 proportions involved in the procedure. The only procedure we know that involves multiple proportions or testing among multiple proportions for hypothesis testing is the chi-squared one-way test that we've been doing in the past. So we're going to actually take the 13%, the 20%, the 67% here, and we're going to use them as our claim for the problem. So let's start out with that first. The government's claim is that essentially those are the correct percentages for each category. So we're going to say that the government's claim is simply that the proportion of uninsured is equal to 0.13. The proportion of people who buy it through the private sector is 0.20, and the proportion who purchase it through their employee health plan is 0.67. You'll notice that this adds up to the 100%, which is required, right? 13 and 67 make 80, and 20 makes 100, right? All right, now the HO, the null hypothesis, is the same as the claim because all these symbols are dealing with equality, right? So it's 0.13, proportion of private sector purchasers is 0.20, and the proportion to get it through the employee health plan is 0.67. All right, now HA is the alternative hypothesis, and this would say that at least one of these differ, right? At least one proportion differs from the government's claim, right? The gov's claim. All right, now from there, what we want to do is to organize the data, and we want to use this data to calculate our test stats. So we start out by listing all the observations in a single column. So 315, 252, and 1,533. Those are our observations. Then we're going to do in the next column the expectations, right? What we expect to see happen. Now the expectations are going to be found after we total up the observation column to see what the total is there. Let's do that together real quickly. So I have 315 plus 252 plus 1,533. We get the answer 2,100. So the observations are 2,100. Now the expectations are going to come from multiplying this total 2,100 times each of these decimal percentages. So we'll do 2,100 times 0.13. This will give us the answer 273, meaning that's what we expect. If 13% of the public is uninsured, then 13% of 2,100 should be the amount that's uninsured in our survey, right? And then we'll have 2,100 times 20%, right? So a fifth of it is 420. And then we finally do, for the last part, 2,100 times the percentage that's supposed to be from the employer purchasing plan. So the employer purchase plans give you 1,407. That's the expected amount of 2,100 that should have their insurance through their employer. Okay, so we filled out the expectations. Now we do observed minus expected. That's the next step. So do observed minus expected, we just subtract these, right? So we literally will just say 315 minus 273, right? Then we'll do 252 minus 420, right? So in that case, we'll have 42. Then this one will be negative 168. And then finally, 1533 minus 1407. And when we're done, we get the answer 126. All right, that's observed minus expected. The next procedure then is to take that column and square it. That's our next step. So we square 42, and we come up with 1,764. Then we square 168. Remember, we don't have to worry about the negative because when you square it, it would become positive. So 28,224, right? And then 126 squared. And we get 1,876, right? Sorry, 15,876. I said 1,500. It's 15,876. Okay, then we're going to do observed minus expected quantity squared divided by E. Okay, so we divide this whole column by everything we see in this column, one by one. So 1764 divided by 273. And we get the answer is 6.4615, let's say. Then we're going to do 28,224 divided by 420. And we get 67.2. And then we'll do 15,876 divided by 1,407. And we'll get 11.282836. Okay, so I round them all out to 4 decimal places, right? Now we're going to total that column, and when you total that column, you get your chi-squared test statistic. So it's the sum of this column that gives us your chi-squared test stat. All right, so let's see what that works out to be for us. So we have the 11.2836 added to 67.2 added to 6.4615. And we get this very large sum, 84.9451. So that is our chi-squared test statistic. All right, now we have our chi-squared test statistic. Let's go find our critical value and compare the test stat against that. Okay, so let's draw a picture of our chi-squared curve, what it looks like. Okay, so it's kind of like a, almost like an F statistic curve, right? It has that same kind of long right tail skewed there on the right-hand side. And what we're going to be doing, of course, is looking at where this rejection region begins in this step. We want to find the critical value, right? So where does that rejection region start? Well, it's going to be a chi-squared value that we're looking for, and it's going to basically be alpha comma k minus 1 degrees of freedom. That's how we're going to look it up. Well, in our case, for our problem, alpha wasn't given, so we'll assume it's 0.05 as a default. And k minus 1 means how many cells or how many categories do we have minus 1. So in this case, it's 1, 2, 3 minus 1, or 2, right? 2. Okay, so now that we know that it's 2 there, let's go and take this and go to our chi-squared chart, look up the alpha, the chi-squared, or sorry, the k minus 1 degrees of freedom, and we'll get our critical value. So we're in the 0.05 column down to 2 degrees of freedom. Let's go check that out and see what we find. Okay, so I'm on the chi-squared table with 0.05 and 2 degrees of freedom. We get the answer 5.99147. Okay, so our critical value turned out to be 5.991. And now we're going to compare that against our chi-squared test stat from earlier. Now our chi-squared test stat, remember, was 84.9451. So the chi-squared test stat clearly lands in the rejection region. So at that point, we're going to say that we should reject HO and support HA. And of course, when you decide that you're rejecting HO and your claim is HO, you have to say the sample data warrants rejection of the claim. So the sample data warrants or allows rejection of the claim. So rejecting the claim that those proportions are exactly what the government says they are. That's it.